Welcome students to solving exponential equations using logs. So on the last lesson you learned what logs are, and if you follow directions you will have already checked in with me to make sure you understand how to do this, because you're going to need this to do this. But aside from that, this is pretty easy because it is nothing you don't already know and have not been doing all year. So you're going to be doing reverse PEMDAS. And when you get to this step up here, you're going to use a log to free your x from its tower prison. So the first thing you want to do is simplify this side if you can. So if you have any like terms you can combine or anything, get that out of the way. Now we don't on this problem, so yay, that's done. Then add or subtract to try to get the exponential part by itself. So basically I want this by itself. So want by itself, and that's going to be true on all of these. You just want to get the number to its exponent all by itself and get rid of everything else. So I'm going to first add 4 to both sides, just like you normally would. Cool. And then you're going to divide by 6, again, just like you normally would. Okay, cool so far. So now you're on step 3. You need to undo the base of the exponent and free your x from its tower prison. Convert to log form. So remember, that's when we took this. So you take this format and convert it to this format. So I'm going to take that base and bring it just to the subscript. The exponent is going to go on its own on the right side. On the former right side of my equation, which is that 9 right there, it's going to become the argument of the log. So, in fact, I'm going to write that little conversion up here so we don't have to keep flipping back and forth. So b to the x equals y converts to log base b of y equals x. So that way we can refer up there instead. So start by writing log. Then the 2, which is the base, becomes the subscript. 2. Then that 9 becomes the argument. So this number goes here. And then the exponent ends up all by itself. So the exponent is going to end up all by itself. Cool. Yay. So now remember, log base something of something else is just a number. As long as these two things are just numbers, then this is just a number. Because log is just a thing that you do. Okay, so let's do log base 2 of 9. So log base 2 of 9. And right now I don't want to round it too much. In fact, I could leave that to do until the end, but that tends to get people a little bit lost. So I'm going to go ahead and put a decimal, but I'm not going to round it too much. Okay. Then I'm just going to proceed like I normally would with PEMDAS in reverse. So add 6. Oops. I just got rid of that. And then finally divide by 5. And we get x equals 1.834. Let's round it to 3 decimal places again. So that's basically it. So it's just your favorite thing, reverse PEMDAS with the logarithm step. So let's try one more together, and then you're going to try one yourself. Okay, so let's try example 1, which is really example 2, I guess. All right, so first, if there's any like terms or anything to combine, I'm going to take care of that. But there's not. So the next thing I want to do is cancel addition and subtraction. And then this is what I wanted to get by itself, just the number to a power. So I've got that. So then I'm going to take my exponent to log conversion and go ahead and write it in logarithmic form. So the base is going to go to a subscript. So the base 9 is going to become a subscript. So log base 9. And then remember this number. So this number right here is what used to be on the right side by itself. So I'm going to put that next. So 78, it used to be on the right side by itself. It's now becoming the argument of the log. And then finally, remember the exponent ends up all on its lonesome on the right side. So I'm going to take the exponent, which is n plus 10, and put it all by itself on the right. And then go ahead and get a number here. Okay, so log base 9 of 78. Is that a lovely number? So again, it's actually better if you don't do this until the end, but since that does tend to confuse people, just don't round this too much. I'm gonna go about there. And then finally subtract 10. And I get n equals negative 8.017. And I'll just leave it at that, 0.17, approximately. All right. So then go ahead and try example 2 and come back to check your work. So for this problem, we should have first added 5 to each side. Then you end up with the power on its own. So you can go ahead and convert to log form. So I get log base 11 of 59 equals n minus 8. So log base argument exponent. And then that gives me approximately 1.70047 equals n minus 8. And finally, I add 8 to both sides, which gives me approximately 9.7.